Hello everyone, I am Madhulita Sundare, Associate Professor in Physics from KG Reddy College of Engineering and Technology. Today we will discuss about black body radiation and first we will discuss about what is a black body, then what is black body radiation and construction of black body and the energy spectrum for a black body radiation. Let's get started. See here on this picture what we are getting to know when candle is glowing, then we can able to see that candle is reflecting to our eye, then we can able to see the candle light. And here one object is here, one dog is here. When it will falls, that ray will fall on the dog and reflect back to our eye. In both the condition we can able to see the object visible to us only when the light comes back to our eye. It's okay. If I am taking here one pot is black and the one plant is here, the leaves are green. Okay, see here when that candle is glowing here and it is reflecting from the leaf, we can able to see that leaf color, it is green in color. But when you see here, when the light is falling on that pot, it is black in color, it is not reflecting to our eye, so that it is invisible to us. So that if the light does not come back to our eye after hitting an object, then that object is invisible or black to us. That's why black is the absence of the light. Black color is the absence of light. Now we will discuss about what is a black body. How we will know that it is a black body. When that is a black body is a body, the absence of light. Then see here, whenever radiation hits an object, these three types of physical phenomena can be possible. One is reflection. On this diagram you can able to see. One is reflection, second one is absorption, and third one is transmission. Then what is a reflection? All of you know already about this. When the object will fall on, when the light will fall on that object and reflect to the same medium, that is a reflection. What is the meaning of absorption? When the light will fall and it will not reflect and transmit, it will all the light will be absorbed on that body. What is a transmission? When the light will fall on that body and transmit to the other medium. Okay. Then this is a transmission. Okay. This is the three types of the phenomena, that is radiation, reflection, absorption and transmission. But here we will discuss about only reflection and transmission. Sorry, reflection and absorption. On this slide, we will see about what is a absorption coefficient and what is perfect black body. How we will say that it is a perfect black body. See here, sun is here. When the light is falling on that object, what is the absorption coefficient? When the light absorbed by the body, how much it is absorbing the radiation, that is known as the absorption coefficient. It may be 20%, 30%, or 50%, or maybe 100%. When it is falling here light, when the light is absorbed 100%, that is known as absorption coefficient of that particular body is 100%. Here one carbon black is here. If you say that it is 99%, means it absorbs the incident light up to 99%. Then you will say that this carbon body, carbon black having 99% of absorption coefficient. Here we will say that here 100% of absorption coefficient. When the body absorbs 100% of absorption coefficient, then it is a black body, perfect black body. If 100% of radiation occurring on an object is absorbed, it is called a perfect black body. See, one question is here. You should go through that question and I am giving a 2 minutes of time. Just think about it. What is the question here? A black body is defined as a perfect absorber of radiation. It may or may not be a perfect emitter of radiation. Is it true or false? Black body, it is absorbing and it may or may not be a perfect emitter of radiation. Is it a black body? Yes, true or false? Just take 1 to 2 minutes of time. See here, the answer is false. Okay, why it is false? Because a black body is defined as it is a perfect absorber and a perfect emitter also. Okay, it will emit all the radiation whatever absorbed by the body. Such a body would absorb all radiation falling on it, and it will emit all the radiation whatever it absorbed by the body. So it's a false statement. See here, what is a black body radiation? Okay, what is a black body radiation? See here, sun is here. The temperature of the sun is more than the surrounding temperature. What will happen here? Though when that light is falling on that object, the object will absorb the radiation, and what will happen? The temperature of the body will be increased rather than the surrounding temperature, but rather than the normal temperature. See here on this picture, if you will give any radiation to that body, it will absorb that radiation, and it will increase the whatever the normal temperature, than that normal temperature it will increase the temperature of the body. As a result, the temperature of that body increase in comparison to its surrounding. So that what will happen to the next, when it is absorbed that amount of energy, then after some time what will happen, it will radiate the energy. Black body, it will radiate the energy. Then the black body starts emitting radiation. Whatever it is absorbed by that body, it will emit the radiation. This radiation is called a black body radiation. Then what is a perfect black body? A perfect black body, it can absorb all radiation of all wavelength of light, and it will emit the all wavelength of light. It will absorb how much wavelength it is absorbing, all wavelength, and it will emit the radiation of all wavelength of light. Then next we will go for what is the construction of a black body. What is a construction of a black body? Here a hollow sphere is here, metallic hollow sphere. It is filled up with a black lamp black. Okay, it will absorb 99% of the radiation. It is constructed by the scientist in the laboratory. So here in this way, what will happen here? A small hole is made, and exactly on the opposite face of a small pointed projection is made. When radiation enters the hollow space through this hole, it undergoes multiple reflection and gets totally absorbed. Thus, such a sphere acts as a perfect absorber of radiation. When this body is placed in a bath of higher temperature, heat radiation comes out of the hole. Now, this hole acts as a black body radiator, and the radiation coming out from that pinhole, that is known as the black body radiation. This is made in a lab. See here on that pinhole the radiation is coming, that is known as the black body radiation. And next we will go for the what is the energy spectrum, distribution of the spectrum of energy in a black body, theory of black body radiation. This is a graph between wavelength and emittance. Emittance is energy radiated per unit area per unit time. So when you are taking wavelength along x-axis and the emittance along y-axis at a particular temperature, what is the temperature here? T equal to 4000 Kelvin. For that particular temperature, 4000 Kelvin temperature, for that particular temperature, when we are going on increasing the wavelength, the emittance is going on increasing up to a particular wavelength, that is peak wavelength. That arrowhead, that red arrowhead it is showing here, that is a peak wavelength. After that it is going on decreasing for that particular temperature, so that here the peak wavelength is in red zone. So we can able to see that black body, it is in red in color. Black body means it will not be only the black color, but it can be in any color. Okay, see next, if you are going on increasing the temperature, I am taking here 5000 of Kelvin of temperature, then the curve is going on increasing and the wavelength is shifting towards the left. Here the wavelength region, peak wavelength region is a green region, so that the black body color here is green color, and after that peak wavelength it is going on decreasing. And see, this is our graph between wavelength and intensity radiation or emittance. Here for different temperature we are taking T 2000 Kelvin to up to 5000 Kelvin. See that peak wavelength, it is going on decreasing towards the left of the graph. Here first curve is 2000, it is on this, then another one is 3000 Kelvin, it is going to yellow region, then it's going to blue region. What's the conclusion from that graph? At a given temperature, what is happening? The energy is not uniformly distributed in the radiation spectrum. It is not uniformly distribution. What is happening? It is going on increasing first, then it is going on after peak wavelength, it is going on decreasing. So second point is, at a given temperature, the intensity of radiation is maximum at particular wavelength, that is peak wavelength lambda m. And third point is, with increase in temperature, lambda m decreases, shift to lower wavelength region. So that the curve, peak wavelength curve, it is going to left side of the curve, that is shifting towards the lower wavelength region. Then fourth point is, for all wavelengths, an increase in temperature causes an increase in energy emission. So when you are going to increase the temperature, it will increase the energy emission. Thank you.